Namaste dear learners. Today we are going to see simple and striking concept in the chapter of lasers, and topics are basic definitions of lasers. In this video we'll see the contents acronym of laser, basic definitions which includes absorption, spontaneous emission, stimulated emission, metastable state, and we'll see the phenomena of population inversion and pumping. Firstly, we'll see acronym of laser. So it is light amplification by stimulated emission of radiation. So light is going to be amplified in laser and by the phenomena of stimulated emission, and that's radiated out from the source. That's called laser. And the next one, absorption. So the general meaning of absorption we know that is taking. Now, for example, if I take two energy states E1 and E2, E1 is a ground state, E2 is an excited state if I consider. Now, if we give an energy to this one, so the particle can absorb that energy and it will move to the E2 state, means the particle get excited. Now how much energy we need to give for this one? It is the difference between this E2 minus E1 energy. If we give it to the ground state particle, that move from E1 to E2, so that phenomena is called absorption. And when absorption needs to takes place, that depends on the energy. How much absorption takes place is depends on the energy given and number of particles exist in the ground state or lower state. And we can define it in proper way that absorption is a process in which specific energy is absorbed by the particle, resulting in the excitation of electron from lower energy state to higher energy state. Now another phenomena is spontaneous emission. Again, if I consider the states, now the particle is in excited state already, but how much time it will stay here? That is around 10 power minus 8 seconds. So this is called lifetime of the particle. That is, the time taken by the particle to stay in excited state is called lifetime, that is around 10 power minus 8 seconds. What happens after 10 power minus 8 seconds? Automatically or spontaneously the particle will come to lower state like this. And when a particle come to lower state, that emits a energy, that emits a photon. So again, what is the energy of emitted photon? Same, the difference between the two energy states. So generally this we can write it as h in u. And clearly we can define it as it is a process by which excited particle independently return to lower energy state and emits a photon in the process. And here we don't use any external energy. So de-excitation happens automatically. Now come to another and important phenomena in lasers, that is stimulated emission. Now again the thing is same. Now if I take E1 and E2 two states, E2 as usual excited state I am taking it. Now suppose if I don't want to keep this particle here for 10 power minus 8 seconds. Before that lifetime only I want to get this particle to the lower state. So what we do is we will give a photon here. We'll give energy I mean, and this applied energy stimulate the particle to the lower state, and particle come to lower state. As a result, two photons will be released. So let it be, this is applied photon and this is emitted photon. And interesting thing is, whatever it may be the characteristics for the applied one, like wavelength, frequency, phase, all these things are same for this photon also, which makes the laser is more different characteristics. And we can define this one as stimulated emission is a process by which an incoming photon causes an excited particle to de-excite or emit a second photon that is identical to the first in energy, phase and direction. So if you observe carefully, guys, so I applied here one photon, I received, I mean, as output we got two. So can I say this one is amplification? So if you see the laser acronym also, we have set light amplification by stimulated emission. This is the phenomena. So we'll get amplified light, we will get by using a phenomena of stimulated emission. In fact, it is the principle of laser. Now we'll see another important small definition here, that is metastable state. Suppose if I consider, let it be three energy states here, and E1, E2, E3, right? So as of now our knowledge is E1 is a ground state and E2, E3 are excited states. Suppose if I say this E2 is a metastable state, if it is metastable state, then what happens is particles will be stayed for sufficiently long time. This will be stayed for long time. Means what is the lifetime in even state? It's very large. So until you are giving external energy, the particles will stay in this even state. It's a more stable state, ground state is. Now if I say E3 state, E3 is excited state, just normal excited state. The lifetime is around 10 power minus 8 seconds, as I said before. But in some materials and in some states, the particles will be stayed for sufficiently long time. So more, I mean more than 10 power minus 8 seconds. And again, that doesn't mean that 1 hour or 2 hours like that. They are going to be stay in E2 state around 10 power minus 3 to 10 power minus 4, like that. So little bit more than this. So such energy states are called metastable states, and the availability of metastable state is very important while while producing laser. That is called metastable state. So it is an excited state where the particles will be stayed for sufficiently long time. So as I said, the excited energy state where the particles will stay for sufficiently long time than its lifetime, and the lifetime in metastable state is around 10 power minus 3 to 10 power minus 4 seconds. Now another phenomena, population inversion. What is meant by population inversion? We'll see. Again, if I consider three energy states, let it be here E1, E2, E3, and N1 is the number of particles in E1 state, N2 is number of particles in E2 state, N3 is number of particles in E3 state. And for a general thing, normal in any system, more number of particles are available in lower states than higher states because of its stability. Ground state is more stable now, so more number of particles are available in even state. So we can write N1 is greater than N2, N2 is greater than N3. Means more number of particles in even state than E2, more number of particles in E2 state than E3. Now suppose I did some process here. By that process, I send more number of particles to E3 state. Let it be this is the situation. After the process, this is the situation. What happened here? Number of particles in E3 state are more than number of particles in E2 state. Fine. And this is the condition I got it. And this situation is only called population inversion. So making more number of particles in excited state than lower state. And one more thing, when we discuss this population inversion, we should compare only the neighboring state. You should not compare E3 state and even state. We must compare E3 and E2 states only. You should not compare E3 and even states. So once I am telling you, population inversion should be considered between neighboring states, should be considered only neighboring states. Now the same thing we can represent in another way, like this. See, this length of this one refers to number of particles. Here N1 is greater than N2. This is the situation before population inversion. Now after population inversion, more number of particles in excited state. And I mean this one is E2 state, this is E1 state. This is E1 and this is E2 states. So again, that should be considered between neighboring states only. So this is the situation after population inversion. And here number of particles are more in higher energy level than lower energy level, and in that case lower state is called negative temperature state. So here this E1 is called negative temperature state. In the previous slide, here in this case E2 is a negative temperature state. When the population inversion takes place, the lower state is called negative temperature state. Now let's see the another concept here, pumping. So to understand it, pumping, let's see this population inversion once. This is a diagram taken from population inversion slide. So the process, right? So we this is the before population inversion, this is a situation after population inversion by using some process, right? And that process is only called pumping. So how can we define the pumping now? It is the process used to achieve population inversion is called pumping. So by using pumping only we will get the population inversion. To sustain with the population inversion we need metastable state. And how that laser is emitted from the source, that we will discuss in the future videos. Fine. So thank you guys, and the write up for the topic is given in the description. So that link is given there. So if you want a write up or notes for these topics, so you can download directly from that. And like, share and comment the video, and please subscribe my channel Physics-Quantas. And once again, thank you very much for watching. For more updates, subscribe my channel. And if you have any questions, please post it in comment section. Or if you want any videos to be uploaded, please tell us in a comment section. By that we can upload for your convenience. So thank you once again, guys. Happy learning.